All right, so welcome to my live stream. Welcome back to Excel Island. If you're an existing subscriber, or welcome if this is your first time on the channel. Don't forget to smash that subscribe button and give this video a thumbs up. So basically, what I've been doing on this channel for the past 43 days is I've been live streaming my learning journey to learn SQL using the Datacamp platform, using the resources from the Datacamp platform. I'm currently subscribed to a 1 year subscription on the platform and I'm trying to maximize it and make good use of it. So I've been consistent for the last 43 days. Yes, today is day 43. So if I complete a couple of lessons today, I will achieve the 43-day learning streak. So that's what I've been doing. I also share content about Excel or Power BI, Python, and SQL on this channel. But right now, you're only going to see content on Excel and the live streaming about SQL that I'm doing. So those are the two major things I'm currently focused on. Also, I share content about freelancing, remote work, and how to become a successful freelancer. I'm currently top rated plus freelancer on the Upwork platform. Sorry. So, and I'm trying to use that knowledge to transition to LinkedIn, the Mojo website, and use those tips and tricks I've used on the Upwork platform to also achieve same success on other freelance platforms. And what have really helped me so far for the last 2, 3, 4 years that I've been a freelancer is I have a coach who has been actually coaching me about freelancing. So his name is Dengadebi. So I currently has a course called the Freelance Client Magnet course. And what the course does is that it teaches you how to become a successful freelancer and navigate the freelancing world and have a successful freelancing business. So this course teaches you how to become a successful freelancer using platforms like Upwork, Fiverr, LinkedIn, and remote job websites. Actually, you can also use your social media platform to 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 like optimize your social media platform and position yourself for your freelancing business. So this course teaches you all that. I'll leave a link to the course under the YouTube description. To make sure to check it out. So you can also check out Benga's B profile on Twitter. I'll leave a link to Benga's B profile on Twitter. Or just go to Twitter and search Benga's B. Check out his print tweets and you see a whole lot of testimonials from students that he has coached. So he's a highly rated freelance coach. So he has over 20K followers. That shows how journey is. And you can check out his work, his print tweets that has over 15,000 views and impressions. You'll see a lot of testimonials from his print tweets. So let me go back to the platform, to the data camp platform. So I'm currently on these functions for manipulating data in SQL. Sorry about that. So far, I've been consistent for the past 42 days. So I completed a couple of lessons today. Today is Saturday. I have achieved the 43-day learning streak. So I'm currently taking the career track on the platform, which is the SQL data analyst in SQL career track. So you can see that there. So there are other courses. So after the SQL career track, I'm moving to the Power BI data analyst in Power BI career track also. So that's the goal. But the goal is to be consistent for the next 100 days, and I'm able to achieve that so far. So this career track contains 11 courses, which is over 39 hours, probably over 39 hours with one project at the end. So far, I've been able to complete 5 courses, and I'm currently on the 6th course, almost through with the 6th course. I have only just one chapter left for the 6th course. So today and tomorrow, I should be through with this chapter and move on to the next, which is Introduction to Statistics. And I still have like 5 more courses to go with one project. So I'll just go back to the beginning and continue the last chapter of the current course. I feel I'm talking too fast. Yeah, probably. So I'll just continue from here and complete a couple of lessons and achieve my daily goal of learning for 35 minutes, or let's say 30, 45 minutes, 1 hour every day. So that's how the amount of time I spend on live stream and learning every day. And the idea is to learn as little as possible and compound this knowledge over time. It becomes cumbersome. So that's, learn a little, practice, make sure you understand it, move to the next one. So introduction to full text search. So this is the last part, the last chapter of this course in the track. So there are courses in the track. So the total course in the track is 11 courses with one project. So each course has 4 chapters. So for this particular course, function for manipulating data in PostgreSQL, I've completed 3 chapters. So this is the last chapter of the course. Let me show the slide and just download it. So I'll just quickly download the slide. So I already have the slide open in my next screen so I can follow the instruction. So I can follow the instructor as he reads it. So I always compare. Let me just show. Why does one get sleepy? Maybe you try to learn something. I think that's one of the challenges with online course. Start feeling sleepy. So I don't know. Most people prefer physical classes compared to online classes. I'm just trying to open the slide on my second screen. Then we can start.
Great job! The last 3 chapters have explored many of the built-in functions available to you in PostgreSQL that will become invaluable skills for transforming and manipulating data using SQL. In this chapter, we are going to get a bit more advanced and explore some of the features of PostgreSQL that allow you to extend its capabilities using custom code. In this chapter, we'll explore an introduction into the full-text search capabilities of PostgreSQL that allow you to improve the manner by which you search text columns in your database. An overview of how to extend the features and capabilities of PostgreSQL using extensions. And finally, we'll explore how to improve full-text search with extensions and some advanced capabilities that you get when you combine the two. If you remember back in the prerequisite material, the like operator can be used in the where clause to search for a pattern in a column. To accomplish this, you use something called a wildcard as a placeholder for some other values. There are 2 wildcards you can use with like. The first is the underscore sign, which matches exactly 1 character. The second is the % sign, which will match 0 or more characters of variable length. In this example, we use the % wildcard to match any title from the film table that starts with the word elf, followed by 0 or more characters. Changing the position of the % wildcard in our query produces a very different result. In this example, we use the % sign wildcard to match a string that begins with 1 or more characters, followed by the string elf. Like is a great tool to use when searching for specific characters in a string. Sometimes when you are performing a text search, you will want to match variations of the characters you are searching. For example, using like to search the title column for any string that contains the word elf in all lowercase will return 0 results. This may be counterintuitive to what you would expect because the like operator matches the exact characters in the query and is case sensitive. However, look at this query, which performs a full-text search by using the functions toTsVector and toTsQuery and the match operator to search the title column. Because full-text search accounts for variations of the search string and is case insensitive, you will notice that you get the expected results. So what is full text search? Full text search provides a means for performing natural language queries of text data by using stemming, fuzzy string matching to handle spelling mistakes, and a mechanism to rank results by similarity to the search string. Full text search can get complex, but even a basic full text search query can be a very powerful tool. The example you see here is a basic technique for querying a document, in this case the column title, to match the characters ELF. The where clause of the query uses the match operator to compare the values returned by two built-in functions to perform the search, toTSVector and toTSQuery. These functions convert text and string data to a TS-vector data type, which is a sorted list of words that have been normalized into variants of the same word. These variants are called lexemes. All right, let's get reacquainted with the like operator and compare it to basic full text search results.
Okay, so review of the like operator. I still remember like pretty well there. So the like operator allows us to filter our query by matching one or more characters in text data. By using the percentage wildcard, we can match one or more characters in a text string in a string. This is useful when you want to return a result set that matches certain characteristics and can also be very helpful during exploratory data analysis or data placement tasks. Let's explore how different uses of the percentage wildcard will return different results by looking at the film table of a circular DVD rental database. So the instruction says, instruction 1 of 3, it says select all columns for all records that begin with the word gold. All columns for all records that begin with the word gold. That's quite funny. Where we select star. Oh, select star. Like, that would be like, I'm running the code. So select all columns. We did from film, where title. So something is missing. By selecting all columns, we are going to get error. Instead we select the film title, except that the film title column. Which is not what they want us to select. Let's select the title column. The instruction says select all columns, but it's not accepting the result of all the columns. It's loading. Oh, okay. Let me use this for the select query there. And this is not funny. I want me to select all columns from same. The easier way to select all columns is just star. This is not funny though, because that's the correct answer and it's not returning any result. But why? Let me shut down, let me close this and open it again. There's no code highlighted there. But what is the challenge? This is not fair. Why do you like wasting my time like this? Oh, I'm missing something. I'm not like this doing mistake. I didn't put, even though select only records, but I using the underscore Wi-Fi now. So I don't need to put the asterisk sign again. That begin with the word gold. It's supposed to work now. Why ask me to put? Let's say begin with gold. Why do you want me to put this aesthetic wildcard again? This is not correct, bro. This is definitely not correct. I don't understand why. I don't know what's wrong with the Datacamp platform now. What's the challenge? Let me copy this. If I click on show answer, let's see what it's going to show. What the heck? Oh man, that's not fair. So I was supposed to change the wildcard, the single sign here. I was really expecting they are using the underscore wildcard here, but I should have thought that that's not the correct answer. See, sometimes you learn. So just saying show the word gold. This is deceiving them. They should have left this place out. They should have left it out for it is translator record that end with the word gold. Okay, end with the word gold. Finally, selector record that contains the word gold. Contains the word gold. So I'm using contains the word gold. So the word gold can be in anywhere. It can be in the middle, it can be in the end. And that is quite funny though. You saw that you saw how to convert you saw how to convert string to CS vector and to SQL in the video. And in this exercise, we are going to dive deeper into these functions. Actually, return after converting a string to a TS vector. So in this example, we convert a text column from field table to a TS vector and display the result. Understanding how full text search works is the first step in more advanced machine learning and data science concepts like natural language processing. Select the field description as a TS vector. So the TS vector description, right? So I want to say TS vector data type. Or is it true or TS vector? Let's say TS vector in description column from field. Let's see that. Maybe I should type the two. Okay, so it has converted it. Yes, when you see to TS vector, I wrote it there. Then you are giving me the error tag. So excellent job. Now that you have seen what a CS vector data type looks like, let's see how we can use it to perform a basic full text search. So what does this look like? Display, 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 So it is taking this description column and turning it to what with single quotes at the end. That's a single quote at the end. Okay. So certain text will become something you do repeatedly when building application or exploring data sets for data science. So full text search is helpful when performing exploratory data analysis for a natural language processing model or building a search feature into your application. In this exercise, we will practice searching a text column and match it against a string. The search will return the same result as a query that uses the like operator with the wildcard, that is the percentage wildcard at the beginning and at the end of the string. But we perform much more better and provide you with a foundation for more advanced filters to query. Let's dive in. So the search will return the same result as the query that uses the like operator with the percentage wildcard at the beginning and at the end of the string. But we perform much better and provide you with a foundation for more advanced full text search queries. Let's dive in. Select title and description columns from the field table. Okay, from film. Convert the title to a TS vector. The title that is to TS vector title. Um, Convert the title to a TS vector and match it against the TS query. TS query of what? Of elf. Okay. Then we introduce the @ sign, the word sign here, TS query of the keyword elf. You have started again, but I thought this is your wrong error. You see? So title, description, where the title is just contains the word elf anywhere. So to just return films, the title and description of film that contain elf anywhere in the world in the record. That's quite funny. Okay, let's do a couple of lessons more. Alright, just starting into the live stream. Let's do this section and practice this. Okay.
The previous chapters in this course have explored many of the built-in functions of PostgreSQL, which provide you with powerful tools for manipulating data using SQL. PostgreSQL also provides you with the ability to create your own custom data types, functions, and operators to extend the functionality of your database. Let's take a look at custom or user-defined data types. A user-defined data type is created using the createType command, which registers the type in a system table and makes it available to be used anywhere PostgreSQL expects a type name. Enumerated data types, or enums, allow you to define a custom list of values that are never going to change, like the days of the week. As you can see in this example, A new data type called day of week is defined as an enum using the create type command with a comma-separated list of the days of the week. Once your custom data type has been created, you can query the system table called pg_type to get information about all data types available in your database, both user-defined and built-in. In this query, you can get the name of the data type using the type name column and the category of the data type using the type category column. The results of the query return day of week for the name of the data type that we just created, and E for the category where E represents an enum type.
Okay.
You can also use the information schema system database, as we learned about earlier in this course, to get information about user-defined data types. If we query information schema.columns and have a look at the columns in the film table specifically, you'll notice that the column name rating is a user-defined data type with a UDT name of MPAA rating. The UDT name column for a user-defined data type contains the value of the name provided when creating the data type using the create type command. You may sometimes find it necessary to learn about the characteristics of your data when working with a new database for the first time. Another way to extend the capabilities of your PostgreSQL data is a UDT name about user-defined data we just created, and E for the category where E represents an enum type. You can also use the information schema system database, as we learned about earlier in this course, to get information about user-defined data types. If we query information schema.columns and have a look at the columns in the film table specifically, you'll notice that the column name rating is a user-defined data type with a UDT name of MPAA rating. The UDT name column for a user-defined data type contains the value of the name provided when creating the data type using the create type command. You may sometimes find it necessary to learn about the characteristics of your data when working with a new database for the first time. Another way to extend the capabilities of your PostgreSQL database is with user-defined functions. A user-defined function is the PostgreSQL equivalent of a stored procedure, where you can bundle several SQL queries and statements together into a single package using the create function command. In this example, we define the function squared that accepts an integer, I, as an input parameter and returns the square of that parameter as a result. The $$ syntax specifies that the function will be using SQL as the language. In addition to being an excellent sample relational database, the $$ function square
Create function square accepts an integer.
Together into a single package using the create function command. In this example, we define the function squared that accepts an integer, I, as an input parameter and returns the square of that parameter as a result. The $$ syntax specifies that the function will be using SQL as the language. In addition to being an excellent sample relational database, the SQL result in the create function command. In this example, we define the function squared that accepts an integer, I, as an input parameter and returns the square of that parameter as a result. The $$ syntax specifies that the function will be using SQL as the language. In addition to being an excellent sample relational database, the Sequila DVD rental database that you've been using as the dataset throughout this course also showcases the power of PostgreSQL extensibility and comes pre-installed with a few examples of custom or user-defined functions for you to explore and experiment with. The getCustomerBalance function takes a customer ID and a timestamp as input parameters and will calculate the current balance of a customer based on a customer ID dataset throughout. Specifies that the function will be using SQL as the language. In addition to being an excellent sample relational database, the Sequela DVD rental database that you've been using as the dataset throughout this course also showcases the power of PostgreSQL extensibility and comes pre-installed with a few examples of custom or user-defined functions for you to explore and experiment with. The getCustomerBalance function takes a customer ID and a timestamp as input parameters and will calculate the current balance of a customer based on a customer ID as of the timestamp date. The inventory held by customer function takes an inventory ID as an input parameter and will determine all rows that have a return date equal to null, which means the customer still has the rental. And finally, the inventory in stock function takes an inventory ID as an input parameter and will determine if a specific inventory ID is in stock. Let's take a closer look in the exercises.
Yeah, let's practice. So, so enum or enumerated data types are great options to use in your database when you have a column where you want to store a fixed list of values that rarely change. That's cool. Examples when it would be appropriate to use an enum include days of the week and states or province in a country. Another example can be the direction of a compass on a compass, i.e., for example, north, south, east, and west. In this exercise, we are going to create a new enum data type called compass position. So create a new enumerated data type called compass position, enum compass position. So we're going to say create type, create type. The name of our type is compass position. Compass position as enum. We call on the enum. Enum. Use four cardinal points. You can use okay. You can use north, south, and east. You can use the north. Uh-oh. It's four now. Either delete one. Create type. Call it compass position. Using the enum function. Enum. You have north, south, east, and west. So verify that the new data type has been created by looking in the PG type system. Okay, create enumerated, confirm the new data type. So we want to select types. I want to say select type name. So that's what we should know. Type name from PG type. So that's where this will be stored. If you create it in your desktop here, where the type name is equals to compass position, name that we created here. You can just double check like that. So that's quite straightforward. Now, getting info about user-defined data types. So the circular database has a user-defined enum data type called MPA rating. The rating column in the film table is an MPA rating type and contains the familiar rating for that film, like PG or R. This is a great example of when an enumerated data type comes in handy. Film ratings have a limited number of standard values that rarely change. When you want to learn about a column or data type in your database, the best place to start is the information system information underscore schema. Then you can find the information about the rating column that can help you learn about the type that can help you learn about the type come on that can help you learn about the type of data you can expect to find. For enum data types, you can also find the specific values that are valid for a particular enum by looking in the PG enum system table. Let's dive into the exercise and learn more. So select column dot name the data type dot UDT name. Select column name data type and the UDT name. Okay. From the information schema, which is not this one. Information underscore schema. Let's select the column name, column underscore name, then the data type of this column, then their UDT name. That is the name given to it, the functions to create those columns. Filter by the rating column in the film table. Filter for the rating column in the film table. Which ratings are there? Oh, you have the rating here. You have G. That will be where rating is equal to which one do you want to have so many things. We have PG. They don't specify the type of rating you should select. But let's go for PG or R. There's PG 13, there's PG, there's NC. I see the rating column here. You have different ratings there. But the only asking us to take two. And the rating is equal to, I'll go for PG. And just let me filter for anyone I like in the rating column. Let's see the results. Wow. There's rating here now. It's saying waiting does not exist. Should we say where the column name? Mm. Oh, I think I figured out my mistake. Okay, the column name equals to rating, and let's see. Well, I can say it is user defined. It's asking me to name a table name. It's not a table name. Since I'm looking at the column in the film table, you're saying this one should be table name. Since I'm using the film table, okay, where the table name should be film. But if I want to use the column name, I have to explain the column in that. Column name from the film table. You're already showing the column name, data type, and the UDT name. Probably if it is numeric or if it is user defined, this only to say user defined data type. Rest are using the end use there. What's the problem now? Where the table name is equal to film and column name is equal to rating. Oh, oh. So you really want to see this table name called film. The column name should be rating, data type, and the UDT name. Correct now. This will give you information about each column in the table and their data type. Oh, that is correct now. Oh, okay. We'll go back real quick. Where table name and the column name that we want. So we only want the column rating and the data type to be shown. Understood. So select all columns from the page data type where the type name is equal to MPA rating. Let's see. So let's start actually from page data type, which is the system, where the type name Let's use the code editor. Basically, I should use column reference, table, and column reference. But why? Oh, I'm using asterisk there. I'm just use asterisk there. That's why. Oh, I'm sorry. I'm using the underscore there. Why now? Type name. CYP. Oh, just CYP name, not CYP dot name. Yeah, I have to look. Not my mistake. I didn't reference the correct column there. This type name here. It is spelled CYPNAME. I'm putting CYPE in the clause. Consider type category of E, which shows is an enumerated data type, which was created, user created different data type. That's what it means there. Understood. Oh, let's finish this last part. Okay, this is the last challenge here. And it says, if you were running a real live DVD rental store, there are many questions that you may need to answer repeatedly, like whether a film is in stock at a particular store or the outstanding balance for a particular customer. The type of scenarios and where user-defined functions will come in very handy. The circular database has several user-defined functions we defined. These functions are available out of the box and can be used in your queries like many of the built-in functions we've learned about in this course. In this exercise, we build a query step by step that can be used to produce a report to determine which film title is currently held by which customer using the inventory ID by customer function. Okay, select title and inventory ID columns from film. Select title from the film and inventory ID from inventory. Inventory underscore ID. That's the underscore ID from film. Join join the film table to the inventory table. So join the film table to the inventory table. Okay, so join the inventory table. Inventory as I on film the film ID. That we use the film ID there. Equals inventory underscore film ID. We have film ID here. Then we have film ID here. So that's our join clause here. That's pretty straightforward. Now select this is inventory ID is currently held by a customer and alias the column as held by customer. So determine whether the inventory is held by a customer. We want to count This will be alias that held by customer. Why do we count that? I want to say, okay, ID, inventory ID, inventory ID. So just count it there. That should be count the inventory ID held by each customer. We're going to be counting this inventory ID from the film. Okay. I need to use a goodbye there. It's not possible. That means something is wrong. I'm missing something here. Held by customer. We want to use this inventory held by customer function. I think so. We're supposed to use that function that has been predefined to do that. So select the screen title. So what this function does is that it shows if it has been held by a customer or not. You can see the title, you can see it just say held by a customer. It assigns 360s to it. So this is that you build a query. Okay. Now filter. Only include result where the held by customer is not null. Okay, we now have to use the filter function there. It will be where everything here. Okay, can I copy that? Where everything here held by customer, where only the exalted by customer is not null. Just write is not null there. So the filter all this null out of the equation. So that's quite straightforward there. But the challenge is how did they come up with this inventory as a customer? The function, that user defined function, how did they create it? Probably in another chapter, we are going to create that. Hopefully, I've gotten the result now. So we are through with that challenge. And we're almost through with this chapter. I am seriously exhausted, but I've learned something today. So I would love to end the live stream here. I'm exhausted, I'm tired. I think it's time to go to bed. So we're almost through with this. I've achieved 43-day learning streak. Yeah. So I'll also end the live stream today. So thanks for staying to the end of the live stream. So if you found value in this video, please do subscribe to the channel and give this video a thumbs up to support the channel and share your thoughts with me in the comment section. Don't forget to check out the freelance client magnet course by Benga DBE. I'll leave a link to that in the YouTube description. And that's all for today. See you on day 44 learning streak. I look forward to day 100. I hope you are too. Smash the subscribe button and put on the notification bell so you can know anytime I go live. So you can